Hello, this is Paul Edwards, and I am doing a short continuing education on adjusting for calcium hypochlorite concentration. As you can see, this is a sight glass, but you know, they don't, after a while being exposed to calcium hypochlorite, there is a discoloration that begins to form inside the tube. So all you need to do is go on and order another one from us. They're not very expensive at all, and we can go on and get that replaced for you and part of your preventative maintenance. As you can see, we have a valve there. You see that? That's the globe valve on this system. And that globe valve can be used to adjust, levels of calcium hypochlorite. And this tube, what it does, the side tube, it creates a range of between 10 and 20, 10 to 30 parts per million right in here. And with a little bit of different engineering on that, we could get you even a lower concentration if you're looking to. But for the most part, in carcass spray applications or primal spray applications, we want to be below 50 and above 10 for that application. So what I'm going to do is I'm going to focus you, and I'm going to make adjustments to this globe valve. And I give you an idea of where that level can change just based on the globe valve adjustment. You got to remember that each stroke of this mini dose pump is only going to give you a what I call a micro amount as compared to your water flow rate. It's a micro amount of solution, and that solution will go on and make contact with the calcium hypochlorite pellets, and then they'll accumulate, a flow will accumulate here in the sight glass. And you have to be very slow in your adjustments here on this sight glass, because you see how it's starting to accumulate right here. I haven't made any adjustment yet. All I did was micro adjust the valve, and you can see that there's a level down at the bottom here, and then it's going to work its way up. You see that? You see that level working its way up there? I'm going to see if I can go on and bring it in closer here. See that micro amount there? Okay, there we go. The micro amount. See that level just kind of teetering? And then what you want to do is, the reason why I call it micro adjustment, it's just it's a scotch turn. A scotch. And we're just talking a small turn that you're going to make to open that up. But I'm going to run this camera here on this surface here. I'm going to let you notice how long it'll maintain within this sight glass, and that's a range, okay guys? I'm not pretending that we're able to control this within a 10 part per million range or a 5 part per million range. There's too many dynamics associated with this controls that would change that. Even making a minute adjustment to the mini dose pump will cause that to change. So the whole idea is just to try to control right here with your globe valve the amount of solution that's accumulating right into the sight glass, okay? So I made a slight adjustment, and the center tube here did not like it, so now I'm going back to correct that adjustment, and I'm going to let that solution accumulate back into this area of the sight glass. So I just got to patiently wait till the level gets from in here up to this top part here. Now folks, this right here is a check valve, and the check valve is a vital part of this design. And the check valve works to manage our stream coming directly from the tablet into the main water stream. Okay. Now the reason why this is not accumulating right now is because we have the globe valve open to a point that when the check valve opens to allow the solution to move into the flow rate of this water flow rate here that's traveling, there's a water flow rate that's running through the main manifold. It allows it a continuous stream to enter into the water stream that's traveling, because the way the check valve works, as long as there's a flow rate going through the main manifold, water manifold, that the check valve will remain open to a slight level. So the check valve is triggered open by the water hydrodynamics that moves through the manifold. Okay, now see that level's come up now? Just needed to get it to accumulate. See that? Level. Sure you can see that it goes up and down. See it coming up? Okay. I'm going to move the camera closer to what we're looking at here. Hopefully we can get a little better image there by moving the camera closer. You see that water flow right there? All I'm doing is I'm putting a light right behind it. A light. This is a flashlight. I'm putting a flashlight right behind it. It's showing you that flow rate. Okay, so I'm just leaving it there. Let you look at this. See that? See that? How it accumulates in there? Staying within that range that we're looking at. That's what we try to achieve here with the system. See, right where you're at right there, it consistently runs around 10 to 30 parts per million, right in that range there. And like I said, we can design this where it continually stays below 10. That's not a problem. We just have to change the configuration of the tablets. Okay, see that flow right there? See, it's going up now. Okay. These systems, they have to allow to be equilibrated, you know. So you have a flow rate that is a continuous stream, a continuous flow rate stream. So what happens is that stream could very well change. When you see that it needs to make a minor adjustment, you can change that globe valve. You can go and open up just a tad. When you open it up just a tad, what that does is that opens up the opening of the globe valve. The globe valve's open, and then that level will change based on that opening. So we're going to let it equilibrate again. So as long as your sight glass indicates that your level is right in here, that you see that, as long as it sees that level there, you're going to be below 50. You can always be below 50 and above 20. See? It's up here now. So I'm gonna show you there. See, it's going up. Now, you might be wondering, okay, what would cause there to be difference here. What would cause that level to go up and down? Head pressure will do that. Any sort of head pressure will cause that to happen. So if somebody closes a valve or reduces the valve downstream to this device, that'll cause it. So you gotta, when you go to standardize your system to maintain a certain flow rate, you have to train your employees not to allow the valve downstream of this device to be reduced, to be closed, okay? If you want to make adjustments, do it with the nozzles, okay? So what you could do is you could have a nozzle that you change, okay? Or it's okay to go on and change that downstream, the flow rate downstream. It's okay to do that, but realize that you may have to make adjustments to the globe valve or your dosematic water flow rate. Okay, so you may have to make adjustments there for the reduced output from the system. Reduced output from the system. So let's say when I talk about output, I know these can be confusing terms. So what I try to do is I try to go on and generalize it a little bit. But when you reduce your flow rate on the outlet side of this device, that will cause this valve to the level within the sight glass to increase, okay? So that would cause it if you have reduced output flow rate, or you have increased outlet side pressure. So if you have head pressure that has caused this kind of like a head pressure that's going to have it backfill, that will cause that also. So just be aware of all the conditions that will cause that. So it's no big deal. Yep, I'm gonna run the camera. I'm gonna go and turn off the camera now, and I think we've covered a lot of good information here. Just keep an idea of where your setting needs to be with this unit, where you prevent this sight glass from filling completely. So you want to understand the dynamics that causes that. When I made an adjustment to the globe valve, what will happen is that you'll start to see bubbles go through this sight glass. The bubbles going through the sight glass means that you're emptying the sight glass at a higher rate than it's filling. So that's what those bubbles look like. I'm going to go in and cause that to occur. Take a look at this right here. You're going to see the bubbles go through here. And what the bubbles are is that the sight glass is starting to discharge into the main water manifold at a higher rate than it is being filled. Okay? I'm going to have you watch that a little bit, and you can track the bubbles that start to go through that. Kind of get an idea of what that looks like. Okay, you see the level here? You'll see how the level has the level is, and I apologize, the sight tube doesn't look very good. I'll probably have to replace that and do a better study. But you see, there is no level anymore. Okay, the level is out. It's really all the solution that was there is gone. See, and whenever I close the valve back up, the metering valve, the globe valve, you'll notice that it goes back up through this tubing, and it accumulates again. So that's pretty much what I wanted to do, is show you how we can use the globe valve to fill this tube and reduce this tube, and as long as as long as the solution is within this tube here, we have found that as long as we're within this tube here, whether it's at the bottom level or to the top, what we have found is that this tube right here represents approximate range of 10 parts per million to 30 to 40 parts per million right in here, okay, depending on what test kit you use. If you use the paper test kit, that's where your ranges are going to be from a visual perspective. But when you use an ampermetric titration, then it's going to be different, because it's going to be a more finite, more closer range. But what we'll do is we'll create some general understanding through our continuing education what it is. But I just want to tell you that center tube there, that's what we're looking to achieve, between 10 and 30 to 40 parts per million, right in there through this tube here, okay? That is established by the base width of this device, the base width where the calcium hypochlorite resides. Well, we appreciate your opportunity for training. If you have any questions, please send me an email at danmarco1@msn.com. That's danmarco1@msn.com. Paul Edwards. We appreciate the opportunity to do this continuing education. We do not give you a warranty regarding this continuing education. It's strictly our opinion what the performance will be of this. You're in control of what the concentration is going to be by your management there at the plant. So just want to let you know that you can get some reliability through the system. So I appreciate your business. Thank you. For any questions you might have, you have a great day.